Good morning students. Today in this video we will learn about the basic concept of differentiation. So now that we have taken a look at the graph as well as trigonometry, let's move on to differentiation as important role in physics of differentiation as well as maths because it measures the rate of change. It measures the rate of change. Now there are two important words here. First is change and second is rate. We will take a look at them one by one and see what they mean. Let's talk about change. Now I have already mentioned that quantity are two types. Quantity are two types. First is constant and second is variable. Constant that does not change, that does not change, and variable will change. Variable will change. Change comes in a variable, and how do we write change? Use the symbol delta. Use the symbol delta for big change or big change, and D for small change. For example, if I have something like this delta x, what does it means? It means big change, big change in x, and I use the symbol. If I use the symbol dx, if I use the symbol dx, please note that d is not a letter. D is not a letter. Here is an operator just like sine or cos, etc. You can imagine this. You can imagine there is a box. There is a box D and X is inside in this box. Its name is D and X is inside the box. So you cannot separate D and X. What I mean to say that if you have something like this, dy by dx, dy by dx, do not cut both d's, do not cut both d's, do not do this, do like this is wrong, this is the wrong. D and x are together, they can not be separated. Or coming back to meaning of dx, dx is equal to change in x, change in x. And what kind of change? Small change in x, small change in x. So when you see dx, think small change in x, and when you see delta x, think big change in x. From now on, Whenever I say change in x, I mean small change in x. So how small change I am talking about? The smallest change that you can imagine is represented by dx. So x changes from x changes from 4 to 6. Is this change dx? Is this change dx? The answer is no. You write here delta x is equal to 4. Sorry, delta x is equal to 2, and x changes from 1 to 2. Still delta x is equal to 1, but x changes from x changes from 0.0000001 to 0.000000001, something like this. Then you can use the phrases dx. If there is something written as dy, it means change in y. And if you have or you can write something like this dt, it means change in t. Change in t. And what kind of change? Small change in t. And d4, d4 d4 means, that means change in 4. Change in 4. But 4 is the constant, right? And constant do not change, and constant do not change. Here constant that does not change, the constant do not change. Therefore what is the change in something that we will not change? Obviously it will be 0. d4 is equal to 0, or d minus 2 is equal to 0, or d1 is equal to 0, and so on. So here is our first rule, is d of constant, d of constant is equal to 0. D of constant is equal to 0. Remember this rule. Whenever we have a constant and d applied before it, then it comes out to be 0. Right now that we know that change means, let's look at the meaning of rate of change, because that word, the differentiation measure, like rate of change is defined as change in one quantity, change in one quantity with respect to other quantity, with respect to other quantity. What this means is, if I want to calculate the rate of change in y with respect to change in x, then we can write as dy by dx. It means change in y over change in x, change in x. And we just learned written as dy by dx. And remember that we will not cancel out the d's, because d is as operator, not letters. So the meaning of dy by dx is clear to us now, means change in y with respect to change in x. If I write something like dx upon dt, if I write something like dx upon dt, then you can understand that it means change in x, change in x over change in t, change in t. And I hope you can write the meaning of uh, dy by dt, du upon dv, etc. Now here is the important part: dy by dx, dy by dx. The process of finding this ratio, the process of finding this ratio, the process of finding dy by dx is called differentiation. Differentiation, and this value is known as, and this value is known as derivative, derivative of the numerator with respect to denominator, means derivative of y, derivative of y with respect to x. The process is known as differentiation and the value is known as derivative, and some people call it differential coefficient, and it is also called as differential coefficient. So I hope that the next time you see dy by dx or dx upon dt and something like this, you will understand what that actually it means. In the next video we are going to take a look at how to actually calculate this value. See you in the next video. Thank you.